You are recording now? Everything is up and running, thank you. Good morning and welcome everybody to this milestone presentation from the data center facility group. I'm happy to let you know one of the milestones in our work with the data center facility is that we started this sub-project by optimizing a modular data center for OCP hardware. And I have 20 minutes. I hope we got time for questions, so I will speed it up and you ask questions afterwards if it's okay with you. We'll launch this sub-project in San Jose in March this year at the summit there. And also, I mean, we have pretty much doing the draft chart before that. So we launched it and also invited the community to work with us. And it was easy to set up a charter here with the main objectives according to the OCP spirit and the criteria. This with the design for maintainability, scalability, energy efficiency for power and cooling, and also minimum viable product regarding robustness. That's the objectives we created for the project. So that's the goal we're aiming for when we start working. We invited the community to take part of this, and we started the work in, I think, beginning of April or something like that. We get the charter approved, and then we start working with it. So the outcome, to give you an abstract here in the beginning, that we are releasing 2 modules optimized for OCP hardware. With those objectives I earlier mentioned, I will walk through them with you in a couple of slides soon. And it's a standalone all-in-one for 12 racks and a scalable module for 30 racks that you can use to scale out your OCP data center when you're deploying that. I keep up the pace a little bit here because I know I'm short of time. So let's start with the optimized design for maintenance. This is one of the main criteria for OCP hardware. It's easy to maintain in front of the server in the cold aisle. And also when you're creating a data center design, you need to be aware of those easy service maintainable solutions for the equipment. And then we started to look after, I mean, you have components like cooling in coolers you need to maintain, and start to asking the vendors and the participants how to really manage to service and maintain those equipment from the front side. And it's doable, and it's easy, of course, with the electrical parts. If you need an UPS, you put it in the end of this rack row, and then you can maintain it. If you don't, you don't need that maintain work with the UPS. You just work with the servers, and maybe if you have lithium-ion batteries, you work with them. Yeah. All maintenance in the cold aisle. In coolers maintained from the cold aisle. You're thinking about the filters. Yes, you did a little bit tricky for the moment. We are using commodity hardware, existing hardware, and I know there's projects going on for developing cooling systems for OCP. I think Rack and Power have a project ongoing right now for that. So maybe if you look into that project, sign up for subscribe for the mail, or dig into the wiki there. You can see the development of the work. And also the cold aisle is best climate zone for technicians to work in. I mean, this is also starting to be really warm environments for technicians. So the less time you need to spend in the data center, the better. And the cold aisle, of course, is much better to be in than the hot aisle. All right. And optimizing the design for scalability, you need to have an idea and design for how to deploy another unit when you scale it out. This is, I mean, you see on the picture is about 2.1 megawatt fully equipped data center. Something like that with 7 units. You can also stack those units 3 stories high. That's the heavy-duty construction we have made for if you have short of land, you can stack them, of course. And you connect the infrastructure, power and cooling from the end of these modules. Fiber and power from one end and cooling from the other. If you use chilled water solution, you place the chillers or the dry coolers on the backside of this solution. Ready to deploy, easy to, you create a big white space, you disassemble one of the walls, and then you connect another module to it, and then you have 60 racks, and you continue to do that, and keeping up the redundancy, and also, I mean, the efficiency of the solution is not depending on how many you scale out. You keep the good numbers for your purposes, and energy efficiency is kept in good condition. That's the scalability. I mean, minimum effort of site assembly is important. It's need to be easy to deploy. And you need to, you need to scale with minimum impact of energy efficiency, as I earlier told you here. I mean, this needs preparation of land with concrete plinths or concrete foundation, or you of course can put it on the ground if you like to. The steel construction is self-bearing, those 2 modules solutions. But I mean, for security reason, maybe you should lift it up 60, 70 centimeters or something, just to take care of water and other threats you maybe have on the site. Cost and time efficient deployment on site. Of course, it needs to be easy to assemble and hook up with a mobile crane, or you can even lift it with a forklift if you have a huge vehicle in place. But the best way to deploy is just using a mobile crane. Hi, welcome. Yeah. That's it when it comes to scalability. Energy efficiency, you can see we have a hot aisle containment here. And you see it's very narrow behind the rack, and that's one of the benefits using OCP hardware. You don't need more than 450 millimeters on the rear side of the rack for the hot aisle to be contained there. And this is the numbers for energy use here is 300 kW with 30 racks. That's a density of 10 kilowatts per rack. But you can increase, if you need to increase the density, you can easily double it up with this solution without any limitation of transporting the warm air, the hot air in the hot aisle. The hot aisle is in enclosure there. I mean, it's around 50 centimeters in this picture. And that also creates opportunities with 2 rack rows in one module. If you need 1.2 meters behind the rack, you can't create the module in this size. This is a size who is benchmarked as cost efficient to transport on land and sea. This is also one of the importance we have made in the project. We have done a benchmark comparing ISO containers with bigger modules, and this size is transportable and cost efficient to transport. So we have performed the benchmark during this. 4.5 width could be for some regulation geographic districts. I mean, Japan, for sure, you have to narrow it down a bit, but in US, in Africa, and in Europe, it shouldn't be any problem to transport those modules on trailers. We have deployed. The design is we have using existing systems, in-row coolers with chilled water or DX for the markets that don't allow chilled waters to be used. Some African countries and so on, you need a DX. But of course, we promote these chilled water solutions. They have better numbers when we are calculating the PUEs and so on. It's much more efficient to use chilled water. And if we come to reuse of energy from those plants, of course, the chilled water as a media is much, much easier to reuse for other purposes if you're going to connect those data centers to district heating system or for other purposes using the energy from the water. That media is of course easier to deploy. Connect it with heat pumps or use it as is. I mean, we have opportunities here with OCP to have great temperatures in return from those data centers. If you compare to traditional, you can boost up the temp. And we are calculating on a chilled water inlet temp on 20 degrees Celsius when we're performing our calculations. It's pretty good, 20 degrees in, and maybe around 28 something out, 30. As a delta T, we could boost that up maybe more. Yeah. Okay. How do I doing in time here, Brevin? I'm still on track. Yeah. Then we need to create some standard for minimum viable product when it regard robustness and looking at best practice and also the markets here, the data center industry. We have created this solution for 60 minutes fireproof, and also Burger Class 2 and in EU standards. I think that will be something called EC3 or RC3, yeah, so if you're familiar with the standards, with steel plates and so in the walls. And also the heavy-duty construction allows you to stack it 3 stories high without reinforcement in the steel frames. So if you like, you can absolutely stack it 3 stories high. Yeah, this is just the bullets for that. Applicable standards also always a discussion. If you can associate the standards to some kind of best practice, the BICSI, of course you have ASHRAE's recommendation, and we have stick to them in this case. If you wonder when we are doing the calculations, we are using ASHRAE's recommendation. Even though it's not needed for OCP hardware, you can have much higher temperature for OCP, but we have stick to the ASHRAE's recommendation if you're familiar with them. So the calculations we are going to present on the documentation at the wiki side is made with the ASHRAE recommendation scope as a reference point. Yeah. And this should be, of course, DCIM IP compatible interface so you can monitor your data center easy. Yep. And just round it up and then questions. I mean, this is extremely exciting to be a part of. I mean, a road to successful open innovation project, it's always this summarizing in those bullets. I mean, ask the end users to participate. We have performed a couple of surveys and addressing the telcos and the colos and the end users of data center. What is your sweet spot in numbers of density? How many racks do you want to deploy when you roll out your next data center? What is your need for scalability? What is the need for density and flexibility regarding that? And always using them as the main input for what you are doing. Prosumers, I heard John Laban call it. That's the production line working with the consumer's impact as the most important input you work with, the in data from the end users. So we addressed in a couple of surveys. That's the way we work in the OCP community. You gather the questions, you get help with the survey, you send it out, address it to the colos, the telcos, the hyperscalers or whatever it is as the receivers, and they fill it in, and we try to interpret it in the best way, and we need to follow it up, and we get some extremely nice, interesting, good answers from them to work with. Of course, we need to involve the top players in the industry. All of a sudden, you have access to the best engineers in the world. Invite the hackers. The OCP community is crowded with skilled people, engineers, technicians who can help you out in those cases, and you invite them all to the table, and all of a sudden your R&D has grown up to 200, 300 people. This is the most exciting thing by working with design thinking. You take the questions and the objective to the table, and then you work it out together with the whole community. And of course, you need to be humble. I'm working on that part extremely hard, because I've been in the industry for more than 20 years, like many of you. It's easy to be a little bit stiff. But you need to be humble to work in these congregations and this method of design thinking, and have big ears and small mouths. Yeah. Okay. It's easy. You take your idea. You access the project lead. I think I started to do one phone call with Robert, who was the project lead at the time. Then Brevin took over, and I have a chat with him. And it's easy to start up. You have an idea of what you like to do, your idea for a sub-project in the group. And I created a simple draft of the charter, project charter, and we refine that and get it approved, and then we start working. And from March until now, we have a great result, I will say. And we are working now with the documentation to get the documents in place and fill up with content. Robert, you're working with the standalone unit, and we are working to fulfill the documentation and definitions for the scale out. So if you have questions regarding the two modules, the two designs, you can ask Robert Bunyer, who is sitting there from Schneider Electric, and come to me, and I'll try to help you up. And we have others in the group, of course, to address if you have specific questions. So this is the way it works, and now we are some kind of handshaking or publishing phase somewhere there, and we are working, and you are welcome to participate with ideas and questions, of course. So this is what we are working in the OCP community. I mean, cost and energy efficiency, openness, scalability, maintainability, and of course, I will declare the numbers of lowering the capex here. It's, I mean, extraordinary. Believe me. You won't imagine what kind of cost efficiency this creates when it comes to build data center. I will speak with everybody later who would like to have a chat around that. We are presenting the technical specs here, and we also, of course, can present the numbers, the calculation costs for producing those modules to you. Okay. Did I manage to keep the time schedule? Have we room for questions, Brevin? Or yeah, we have. Okay. Yeah. So let's shoot if you have any questions. Back.
What sort of PUE figures are you getting?
With chilled water PUE, we get 1.07 when we calculated on 20 degrees inlet temperature for 300 kW. Okay. It's good numbers with in-row coolers, yeah. A little bit higher with DX. And we're presenting the calculations for 2 areas, one in the Middle East and one in Europe. So you can see the numbers, how it works in different countries, different geographic areas. Yeah, Robert?
Just a comment on this project. One of the outputs that I'm actually excited about that I think is good for the market is standardizing the way that we describe prefabricated or modular data centers. It's a relatively new business. I mean, it's been around a while, but it's kind of building now. But you know, if you were to request a prefabricated module from multiple vendors, how would you describe it, right? what's the outline, you know, how do you specify it? And so one of the outputs of this project is to have a nice outline that anybody in the industry can take to either describe a module that they're proposing, or you could use it to request a module. And so if the industry is able to standardize that, it'll make it much more efficient for everybody. So I'm pretty excited about that output from this, you know, outside of the actual kind of specifications of the two particular modules.
Yeah, and we're aiming to create a baseline of standards. It's easy. It should be easy to understand we have a specification summary table that we are putting down those definitions that Robert mentioned. Yeah. Okay. Any more questions? Or there you have one here.
Could you maybe show the picture again of the rack layout inside? That was a little bit quick for me.
That's this one. Or that one?
How many racks?
30. 2 rack rows. Yeah. Per module. Yeah. 15 in each row. Yeah. You can increase it if you have the space, but if you create a big open white space area, you need the aisle to walk through. So we left, and also you can add an UPS if you like to in one of the rack rows. If you prefer using a UPS in this system, you can add it in one of the rack rows. Yeah.
How is the power distribution to the rack? Is there cables or?
Yes. Yes. It's standard cables. I think it's 32 amps, 3-phase to each rack, and then you have a load of 10 kilowatts, and you're using the 48 bar, DC bar in the back of the open rack. This is open rack V2. Yeah. 48 volts, yes. Yeah, if we have a better picture here, we have more pictures, of course, but we wouldn't. You see that one in the that's the main distribution board, the switch. You mean that one for the main power input? Main power. Yeah, main power, and also the breakers for the system is. You see that one in the rack roll? Yeah, it says AC PDU. Yeah, yeah, you have to lean over. Yeah, yeah. Okay. And we have drawings, of course. Yeah, if you go in, we're publishing those drawings and pictures, and also clarifications on the wiki. Yeah. One more question there. Yeah.
How many in-row coolers will you have in this layout?
In this is 12, and a redundancy n+1. And you have maybe 5. So yeah. It's but we have calculated on the density of 10 kW per rack, because when we asked the stakeholders, we ended up they like to deploy between 7 and 12 kW. So, most of them, except the HPC guys, of course. They are increasing the density, and then we need to go for maybe liquid cooling or other solutions. But you can boost this up, I think, to 15 per rack and manage with the design with air-cooled solutions. Yeah, have questions there?
Yeah. Whereabouts do you keep the pipework for the chilled water supply to each of the in-row units? Is that maintainable and accessible?
Yeah, you ask about the supply for the chilled water units outside. Yeah, we put them on the back side. So maybe I have a picture of the whole there. Imagine you have power and fiber from one side coming in infrastructure-wise, and then from the back side you put the chillers, connect them. So the piping is going in from that side. And we are also describing in the documentation how to connect the infrastructure to the module in an easy way. So you maintain those systems outside the module.
But within the actual data center module, where is the piping above the cabinet?
Yes. Yeah. The piping is I think below. Or behind, yeah, in the hot aisle. We're going to produce drawings for the piping and the infrastructure. You have it below as well, or in the top of your units? could be both, I think.
Yeah,
Or-
I think the one design we have is actually just DX. It's a small solution.
Okay, yeah, the media is connected from the back side of the racks. Yeah. More questions?
What's the timeline for this specification to come out?
We are working on it right now. We are, the deadline, yeah, we are. I mean, we try to fill in the content in
Should be definitely before the end of the year. I mean, I'm
yeah, absolutely, yeah. In a month or so. Yeah.
When Arctic Circle presented their design
Yeah.
summit in the year, they talked about having to put in a 19-inch rack for some networking gear because it wasn't compatible with 21-inch rack. So have you allowed for, say, a network rack, bringing in service provider cabling distribution?
I mean, it should be doable. We haven't think about it in a way that we are only using the Open V2 racks here to deploy both server equipment and switch gear. I mean, the routers and so on. Because you're asking about the communication parts.
Yes, the form factor for the
Yeah, yeah,
routers and switches.
yeah, yeah.
May not be 21 inch, so that's why they ended up using
19.
a 19
Yeah, yeah.
rack. The rest of it was 21 with 19 inch for the network.
Should be easy to deploy, I think.
outside dimensions are still 600 millimeters.
Yeah.
So,
Yeah,
yeah.
it's compatible. Yeah. Okay. We have one more question. Okay. If you have. Yeah. Okay.
Is it those?
Then we need to continue. Okay. If you have more questions regarding the modular data center, or we are available afterwards as if you like to chat with me or Rob Bunger there, we can help you, I think. Interact with us in the project. Okay? Thank you. Thank you for listening.